Hi, question number 14. So the question is, which of the following statements is correct for this molecule? And this is SO2Cl2. SO2Cl2. The molecule is SO2Cl2. In fact, it was called as a sulfuryl chloride. Sulfuryl chloride. So to analyze about all these points, it was totally based on the structure. So to concentrate on the structure, we need to have for the hybridization. So simply for hybridization prediction, I will give you a simplest, smallest formula, that is half into Z plus M you can use, where Z is the central atom group number of central atom. Sulfur group number is 6. So you can take 6, sulfur group number is 6, plus M is called the number of monovalent atoms. In fact, you know well, chlorines are monovalent and oxygens are divalent. So 2 chlorines are there, so you can take 2, 6 plus 2 into half, or you take by 2. So it's nothing but 8 by 2, it will be 4. Wherever you got the 4, it's called number of hybrid orbitals are 4, its hybridization will be sp3. Whenever the hybridization is sp3, it should be tetrahedral. If it is ab4, yes, it is ab4 because central atom is 1 and 4 bond pairs. See, pi bonds are not considered as bond pairs because hybridization involves the sigma orbitals, sigma bonds. So it is a tetrahedral geometry. It will be the right answer. Let's check the remaining 4 options are there. What about this? It contains p pi and p pi d pi bonds. It seems to be little new, but it was quite easy. Just observe this one. I told you hybridization of sulfur sp3. So actually sulfur it belongs to 6th group. So it can have sulfur, it can have 3s2 and 3p4. In fact 3d0. But however, it needs the formation of 2 pi bonds and 4 sigma. So it has total 6 electrons unpaired, but it has having paired, and here also some paired. So it has to be excited. So it will be 3s1, 3p3 and 3d2. This will be the final configuration for that, excited. So 3s it will be 1, yes, 1 electron, and 3p orbitals are 3. You know orbitals are 3 and electrons also 3. So 1, 2 and 3. 3d, you know d orbitals will be 5. D orbitals are 5. 1, 2, 3, 4, 5. Electrons are 2. So you can make it 2. Now the hybridization involved, already told that it is sp3. So you can mention that these are involved in hybridization, sp3 forming 4 sigma bonds. So all are sp3 hybridization. They form sigma bonds, all 4 sigma bonds. And now these two are forming the pi bonds. It is a pi bond, it is a pi bond. Observe that both the pi bonds are formed from the d orbital of sulfur. But oxygen has no d orbitals, they can have only p orbitals. So there will be a p pi versus d pi. It is also p pi from oxygen and d pi of sulfur. So both the bonds are p pi d pi. But it was mentioned is p pi is mentioned. So this will be the wrong option. And coming to the bond angle. See, theta 1 is mentioned. Theta 1, this is between an oxygen and oxygen. In fact, in case of SO2Cl2, oxygen bond angle was found to be, between oxygen and oxygen, it was found to be 120 degrees is the bond angle. So theta 1 it is 120. Whereas theta 2 between chlorine and chlorine, see this bond angle chlorine and chlorine was found to be 111 degrees actually. Okay, right. And now this theta 2 is actually low, but here it is not mentioned about theta 2. And theta 3, actually here this value theta 3 between chlorine and oxygen 124 degrees close to that. So theta 3 is more, but it was given as less. It will be wrong. And finally, plane which contains maximum number of atoms is 4. See, I told you this is a sp3 hybridization tetrahedral. I will show you a sp3 geometry for this. Just have a look on this one. So you know that it can have a pyramidal type. This is just pyramidal, and you take one more atom on the top, it will be sp3. It is called tetrahedral geometry. You go with any kind of plane. If you draw a plane coming to this one and central atom and this one, you can have maximum touch with the 3 atoms only by leaving 2 atoms out of the plane. Anywhere also it will be same. It can have 3 atoms as maximum. So it's not 4. So plane contains maximum number of atoms. 4 is also the wrong one. So answer will be B. It has regular tetrahedral geometry. I think, hope you can understand. Thank you.